Now, my dear student, let us proceed with our statements as it is shown here, which explain that suppose that the angle of contact is formed between the surface of the liquid and also the surface of the solid, which is represented by the angle theta, as it is shown on our figure number 6.12, which imply that this is the figure number 12 for our topic number 6 here. Now, on our figure, this y here represent the magnitude of the surface tension of the liquid, which can be determined by considering the vertical component forces. So, in order to identify the magnitude of this surface tension, we should determine, we should consider the vertical component forces as we observe here. Now, this is our figure number 6 point. This is our figure number 6.12, the figure number 12 for our topic number 6 here as we seen. Now, this figure try to explain the title that we looked on the last lecture. We tried to see that how can we measure the surface tension of the liquid of using the capillary tube. This is what this implies the capillary tube, which is used to measure the surface tension of the liquid. So, my dear student, as we seen here, we have our figure that explaining about the capillarity tube. The way we could measure the surface tension using the capillary tube. Now, inside this narrow tube, inside the narrow tube here, we have the liquid inside. We have the liquid, and also on this tube here, we have the liquid that is trying tries at the certain height as we seen here. So, my dear student, from this narrow tube up to a certain point, this represented the height of the liquid on the narrow tube. But as we seen that the distance from here, from this point of the tube here up to the center, represent the radius of the capillary tube, where this R means internal radius of the capillary tube. Kwa hii R tunaita ni internal radius of the capillary tube as we seen here. But my dear student, as we seen, inside of this narrow tube, we have the liquid density. This is the density of the liquid as we seen here. But the angle of contact which is formed between the angle of contact which is formed between the surface of the liquid and also the surface of the solid is represented by the symbol theta, as we seen here, my lovely students. Now, if we try to dissolve this here, my dear student, we should obtain that the force that acts upward must be represented by the force cosine theta, ambao tumesema hapa kwamba kwa kuconsider the vertical component forces. Kwa yule vertical component forces ni sawasawa na F times the cosine theta as we seen here. So, my lovely student, at equilibrium, the vertical component force is equal to the weight of water in the tube. Kwa sasa kwenye equilibrium position, position tutamwambia kwamba always the vertical component, my lovely students, must be equals to the weight of the water in the tube. Kwa ile weight of the water in the tube ni sawasawa na ile vertical component force as we seen here, my lovely students. Now, we should take it and compare. Sasa tutarudi hapa kwamba huyu vertical component forces must be equals to the downward force ambao tunaita ni weight of the liquid. Kwa tutawaikweti pale, mwisho wa siku tutasema sasa kumbe the force times the cosine theta. This theta means the angle of contact between the surface of the liquid and also the surface of the solid. must be equals to the mg. This mg means the weight of the liquid, as we have been told here, my lovely students. Now, as we know that the mass is represented by taking the density times the volume. Sasa kutoka kwenye relationship ile topic yetu ya form 1 ya density and relative density, we know that the density must be equal to the mass times the volume divided by the volume. But here we want the mass. We are supposed to make a mass at the subject, and we should obtain that mass of the liquid must be equals to the density of the liquid times the volume of the liquid. If we substitute instead of writing this mass here, we are supposed to substitute equal to the density times the volume. And after there, my dear student, we should obtain the equation number 11 for our topic number 6, which say that force times the cosine theta must be equals to the density times the volume, then we times it by the g, which represent the acceleration due to gravity here. So where V is the volume of the liquid in the tube above the free surface of the liquid given by the cylinder. So V here should represent the volume of the liquid in the tube above the free surface of the liquid, which is given given by the volume of the cylinder at the height this one. Kwa yule volume sasa huyo V atarepresent ile volume of the liquid as we seen here, my lovely students. And it can be obtained by taking the volume of the cylinder of height h, and also the radius plus the volume of the small cylinder enclosed by the hemisphere, then we minus by the volume of the hemisphere of radius r, as we seen here. Now, my lovely student, as we have been told that we get the volume by taking the volume of the cylinder, then we add it by the volume of the hemisphere, of the cylinder hemisphere, then we minus it by the volume of the hemisphere, as we seen here, my lovely student. The volume of the cylinder at the certain height must be obtained by taking pi r square h, kama tunavyojaribu kuobserve hapa. Lakini yule volume of the volume of the small cylinder enclosed, yule volume ya small cylinder ambayo atabini enclosed pale atakuwa ni sawa na pi r square times r, as we seen on our formula here. But finally we minus by the volume of the hemisphere of radius r. Your volume of the hemisphere at the radius r, my dear student, should be obtained by taking it a half, then we times it by 4/3 pi r cube, as we seen here. Then if we simplify this one, my dear student, because have the same radius which involve the exponent of 3. Now if we simplify, we should obtain that the volume must be equals to pi r square bracket h, then we add by r divided by 3. This is our formula of obtain the volume, and this will be our equation number 12 for our topic number 6, as we seen here, my lovely student. So after this one, we are supposed to record the force. How can we get the force? We know that the force, my dear student, can be obtained by taking 2 times the surface tension, then we times by pi r, as we seen here, my lovely student. So after this one, we are supposed to take this equation number 12 for our topic number 6 and substitute into our equation number 11 for our topic number 6. Kwa ukisubstitute pale tutapata sasa kumbe 2 times the surface tension, then we times by the cosine theta is equal to the density times gr bracket h, we add by the third 1/3 times the radius here. Now after this one, because the aim of doing this, my dear student, is to obtain the surface tension, to know how can we measure the surface tension using the capillary. If we simplify more and more, my dear student, we should obtain that the surface tension of the liquid using the capillary tube is equal to density times GR. Bracket H we add by R over 3, then we divide by the 2 cosine theta. But if R over 3 is if the tube is very narrow, we should assume that R over 3 is negligible, na mwisho wa siku tutapata formula yetu, kumbe surface tension must be equal to the density GRH, then we divide by 2 cosine theta. My love, this will be our equation number 13 for our topic number 6 as we seen here. So by saying that this is the end of our session here, my dear student, now I would like to invite you again for another session. I wish you all the best. Have a nice moment.